Given the following function, x cubed plus 3x squared minus 9x minus 27, we are asked to find where the function is positive or negative, increasing and decreasing, concave up or concave down. So to begin, we'll look at the original function. We'll factor it into its simplest form. We factor by grouping. We end up with x plus 3 times x minus 3 times x plus 3. In factored form, we can see where the polynomial is equal to 0, and that'll be where we set these equal to 0. You end up with positive and negative 3. Polynomials exist everywhere, so there's not a spot where it does not exist. With these, our critical values, we can make a sign chart. This will help us to determine where it's positive and negative. So over here we'll list our factors of x plus 3, and x minus 3. And we'll substitute them using our two critical values of negative 3 and positive 3. You'll see we end up with a negative, positive, and a positive, negative, positive, positive, and negative, negative, positive. So the function to the left of negative 3 is negative. It's negative between negative 3 and 3, and it's positive to the right of 3. So positive from 3 to infinity, and negative from negative infinity to 3. Now we'll look at our second derivative. This is going to tell us if it's increasing or decreasing. Using the power rule, we'll just look at the original function up here. To find the derivative, we end up with 3x squared plus 6x minus 9. That will eventually factor into 3 times x plus 3 times x minus 1. Again, looking at it in its factored form, we can see the zeros of the function. Those are negative 3 and 1. Again, since it's a polynomial, it exists everywhere, so there's not a spot where it does not exist. We'll make our sign chart again with our critical values of negative 3 and 1, and our factors listed on the side, 3, x plus 3, and x minus 1. To the left of negative 3, we end up with a positive. Between negative 3 and 1, we have a positive, and to the right of 1, we have positive. And for x plus 3, we have a negative, a positive, a positive. For x minus 1, we have a negative, negative, and positive. So for the first derivative of the function, to the left of negative 3, it's increasing. Between negative 3 and 1, it's decreasing. And to the right of 1, it is increasing. So again, in interval notation, f is increasing from negative infinity to negative 3, and from 1 to infinity. And the function is decreasing between negative 3 and 1. Finally, we'll look at the second derivative, which tells us its concavity. Using the power rule from the first derivative, the second ends up being 6x plus 6, and we factor that into 6 times x plus 1. And again, we'll set it equal to 0. We're looking at it in factored form, we see that 1 would give us a 0. Again, since this is a regular, polynomial, there's not a spot on the graph where it does not exist. 1 is our only critical number, so we'll put it on the sign chart. Here's our factors, 6 and x plus 1. On the left-hand side, we have a positive, and on the right-hand side, we have a positive, because 6 is always positive. And then down here, we have a negative and a positive. So the second derivative of the function is negative, and then positive, meaning it's concave down and concave up. So again, in interval notation, it's concave down from negative infinity to negative 1, and concave up from negative 1 to infinity.